Okay, so some hints about question 11, which is a velocity time graph. So the things to remember, the velocity time graph, the gradient, which a gradient is delta y over delta x, which in this case y is the velocity and x is the time. So delta v over delta t. You should know that that is the change in velocity over time is the acceleration. So the gradient is the acceleration, and the question is asking you to describe how the acceleration of the object varies with time. So you're looking for key points, you're looking for very specific points here, and you're looking for, well, obviously you're looking for the gradient, which is the slope. So you effectively have two different gradients there, so that's important to work out. And when it says your answer should include calculations, what they need is you need to reference the numbers, and by that you're going to need to reference the change in velocity and the change in time in your calculations. Okay, so that should be enough. You've got 3 marks there, so you're going to probably need not just the numbers and the calculations for the 2 different parts. You probably also need to pay attention to the positive and negative direction. So you notice that this direction is positive and this direction is negative. They've given you these numbers here. So you'll notice that the gradient will change sign from this region and that region. And you probably need to say that for your 3 marks. Okay. Question number 12, sorry. This one, it's an experiment for measuring the acceleration due to gravity, and the student is going to use the equation v squared equals u squared plus 2as, where u equals 0, and a graphical method to determine the value for g. So we're going to be finding out v. And then we're going to be finding out A from that. So we're going to need to know a few other things. And what we're going to do here is if we drop this wooden rod, we're going to need to make some measurements. So what are we going to need to measure? Well, we're actually recording the time, but what time are we recording? We're recording the time for the wooden rod to pass through the light gate. So we're going to need to know how long the wooden rod is. And we're also going to need to know the various different heights. So we're going to, experiment. So basically you're going to drop the wooden rod from a bunch of different heights. So H1, H2, H3, which all correspond to different S. And that should be enough for you to do the first part. Describe how the velocity of the wooden rod passes can be determined accurately. Okay, so you need to work out what velocity is, and you should, if you're working out velocity is equal to the change in displacement divided by the change in time, you've got to be working out how to measure the change of displacement of the rod as it goes through the light gate. So you've got to think about this, how would you measure the change in displacement? And you could pick one point on the rod. So there's one point on the rod, and this point as that moves through the light gate, and that's kind of related to the length of the rod. Okay, so that's enough of a hint there. Describe how the student can determine a value for g using a graphical method. Right, a bit more tricky, because you've got to say, okay, well, we've got to have different heights, H1, H2, H3. You've got to describe how you're going to do that. And then you've got to work out a graph. Now, the equation we're going to be using is v squared equals u squared plus 2as. A graphical method is where we end up with something like y equals mx plus c. and we will kind of use the idea that m is the gradient. So we need to set things up so we can actually plot a y against an x based on these different things and try and work out what the gradient is going to be. Now, to give you a tip on this, u squared is going to be equal to 0, so we can ignore that. So this is going to turn into v squared equals 2as. And then with a bit of jiggery-pokery, you should be able to get that in a format similar to this and work out what to plot. And you probably need to talk about how you set your readings up in a table and then how you draw a little graph. Okay, that should be enough.